you're going to notice in these notes, the first thing we're going to do is graph a sine wave. Okay? Just a plain old sine wave. Yeah, go grab it. Okay? I hope he pressed the two-sided option. You know what I'm saying? Oh my goodness. All right, now, the problem that you're going to have with this particular graph is what? What are you not going to like when you look at this? The y-axis is going to be confusing to you. All right, now I purposely made this scale also in terms of pi. Okay? So, we know that pi is approximately 3.14, correct? So what would that make pi over 2? About what? 1.5. Come on, 14. Cut it in half. Okay, 7. Right. Oh my goodness. Okay. So we know that 0, 0 is on our graph because it's a sine wave. Stay with me. Okay. We know that 2 pi units later, it's repeating the pattern. Halfway in the middle, it's back at that center line. Halfway between the first and third points that I just graphed, we would go up. How high would we go up? We only go up 1, right? The amplitude's 1. But if pi over 2 is 1.57, that puts my maximum value somewhere in the neighborhood of that. Okay? So likewise, to find the last point, I'm going to be guessing like right in there. And then I can find a matching looking image on the other side and then graph it. Does that make sense? Does that make sense what he's saying with the whole pi over 2? Okay. We know that the amplitude is 1, right? But because of the odd-looking scale that I have here, it's kind of hard to read where is 1 on the y-axis. So the distance that I'm highlighting right here is approximately 1 in height. Okay? Now there's a reason I did this scale this way, because, and I know it looks confusing. Torture. Yes. Which is why I'm doing it with you. Okay? Now, do we know the domain? Okay, this should be easy, folks. What's the domain? All reals. Please make sure we keep it all real. All right, now, what about my range? -1, 2. Come on, same thing it's always been. Don't struggle just because it looks kind of weird with the scale. It's just -1 to 1. All right, what does x represent in this particular equation? What are the values that you see on the x-axis? What are they? Okay, they go with the unit circle because they are angle measurements. So what does y represent? What is the sine of an angle? What does that represent on the circle? Is it an x value, a y value, or a slope? There's only 3 choices there, folks. Is sine an x value, a y value, or a slope? It's a y value. So this particular function, angle measurements go in, y values come out. Do you understand that's what this function is doing? That's important that you understand that. What? Okay. Every function in the universe has an independent variable and a dependent variable. Sometimes we call them inputs and outputs. Okay? We put a value in, we do some mathematical operation or operations to it, and a value comes out. So we need to know what's going in and what's coming out. Does that make sense now? Okay. It really kind of is important that you do understand that to do the next part and really understand the next function. The inverse function of sine. You know, if you see it at parties or billboards or commercials, that's what it looks like. Sine inverse of x. Thank you.
What is the most embarrassing thing that's ever happened to you at a math party?
Okay, first of all, they're not math parties, folks. They're just regular parties, okay? You know, dancing, math lyrics to the songs, just regular parties, okay? Like normal people, folks. Okay, nope, don't do it. Don't do it. Okay, thanks. Now, if I asked you to graph the inverse, we all know that in order to find an inverse, you do what with x and y? You switch them, right? So what happens to 0, 0? Nothing. Okay? What happened to pi over 2, comma 1? This point right there. 1, comma pi over 2, which, because these are rectangles and not squares, it's not going to look exactly the same, but I'm going to say it's probably right about in there, because we know, based on the fact that pi over 2 is 1.57, I can't go all the way over to the right. So this is the point, 1, comma pi over 2. So what happens to the point pi, comma 0? 0, comma pi, right there, folks. I actually need it. You need a red pen? You're welcome. Now, how about 3 pi over 2 negative 1? Where does that go? Negative 1, 3 pi over 2. Somewhere right in there. And what about 2 pi 0? Where does it go? 0, 2 pi. Okay. Yeah, yes. That's how most parties get. Oops, sorry. Wrong spot there. Don't keep saying math parties. They're just normal ones, man. Normal people. It's not like we're giant nerds or anything. Okay, we're cool people. Okay, well, some things are best left. Nope, I don't. Well, I didn't say I don't enjoy some things. I just don't, I just don't get drunk and don't spend tons of money on it because that stuff's expensive. Okay, so that's the approximate looking sine inverse function. So here's my next question to you. Is the original blue sine wave that I graphed, is it a function, yes or no? It passes the vertical line test, correct? What about the red one, the sine inverse? No. In fact, I don't know why I circled it in blue. I should have circled it in red. What was that? Okay. It fails the vertical line test, so it's not a function. Okay? That's a problem. Okay? So we kind of have already done, let's see here, in blue, we'll do the blue. We already kind of wrote that up there, so we had all reals for this one, and negative 1 to 1. What about the domain and range of the inverse? What's the domain for the inverse? Ooh, negative 1 to 1. And what about that range? All reals. Oh my goodness, it looks like they just switched. Why does it look like they just switched? Because they did. That's right. The x's and y's reversed, so that makes sense why the domain and ranges are switched. Okay, we already answered this next question. Is the inverse a function? Definitely no, right? Fails vertical line test. Fails vertical line test. Not vegan lettuce tomato sandwich, just vertical line test.
What about vegetables?
Yeah, I feel like that's
I just what veal lettuce tomato, venison lettuce tomato?
Are there any foods that start with
Because it's like BLT, you know, bacon lettuce tomato,
There's no food that starts with
right? Okay,
What?
veal or venison,
Oh,
veal,
you said there are some different with veal.
right?
It's a
Those are baby calves. Those are baby calves.
What
Okay,
meal?
yeah. Yes. What if we restricted, okay, so here's an important question. What if we restricted the domain on the sine function so that the inverse would be a function? That is critical. We're trying to make the inverse a function. But right now we have such a large, we have a problem with the domain of the original sine function. So what if we could cut the domain of the original so that its inverse would be a function? There are 3 criteria that must be met in order to do this correctly. Number 1, the restricted domain must include the angles of a right triangle. So, what would that include? And if you don't mind speaking Radian, that would be wonderful. Right triangles. Folks, what's the largest radian measure angle in a right triangle? Pi over 2, right? Right? Pi over 2 is the largest one you can have. I know you were all thinking 90 degrees, and I was trying to make you convert to radian in your mind. But, so, where would you find these values? Which quadrant of the unit circle would you find these? That's quadrant 1. We just identified quadrant 1, right? So, if I go back to the blue one, and we'll pick green, we just decided that we wanted this stretch of the graph. Okay, that's step number 1. We're looking at the original sine wave, and we're trying to make a decision based on these 3 criteria. Next, the restricted domain must have the same range as the original sine function. So the original sine function had -1 to 1. Now, if you look at the green stretch that I've highlighted right now, what's the range of that green stretch only? Well, that is not what I wanted to do. From 0 to 1, right? Is that equal to the range of the sine function? No, it's not. Okay, so that will be our second criteria that we look at. And the third criteria that we look at, the restricted domain must be continuous. Must be continuous. Now, suppose that I decided, if it's got to be continuous, suppose I decided to add, this part right here. If it's got to be continuous, I started out with the green section because it's got the triangle, the right triangle values in it, and I added the orange section. So my question is, that it is continuous. What's the range of the green and the orange together? What's the range? Still only 0 to 1, right? So if the second criteria that needed to be met was it has to have the range of the original sine function, I would have to go from -1 to 1. So my orange part right there was not a good choice, please. Yes, I got rid of it and not the blue. Whew. So if that isn't a good selection, what about this part? What if I added this purple section? The purple and the green would be continuous, right? Does it have the correct range? from -1 to 1, doesn't it? So if we restricted it from -π/2 to +π/2, what would the inverse look like? The inverse, and I'll try to draw this in orange, the inverse would be this section right here. If you only look, and I'm sorry, maybe I should have chosen like yellow or something. Should I try yellow? Yes. Come on, erase it. Okay. Okay, we'll go with yellow or neon green. Neon green looks cool. So see this neon green section right here? Is that neon green section something that passes the vertical line test? Yeah. It is. So we have met the criteria for the inverse sine function, or for making the inverse sine function or the inverse sine into a function, I should say. Okay. So we took this giant range and we restricted it down to just -π/2 to π/2. And we're going to put some brackets around it because we included the endpoints. What does that do to the range of the inverse sine function? It changes it to what? Whatever that is, yes. Whoa, brackets. Now, where would you find that on a circle? Where would you find -π/2 to π/2? Before we go to lunch, I just want to know where in the world we find that section. Okay, we know that the right triangle stuff has to be included, but where's -π/2 to 0? Down there. So we're talking about the right half of the circle, including the endpoints. I'll just put the brackets because we know that we're including them. Okay? So we're going to start answering some questions in the next part of the video that are asking you specific questions about sine inverse, and there will be only one answer because we just made it into a function.